welcome to today's webinar, Streamlining Your Manufacturing Processes. I'm Barbara van der Walt, the Marketing Manager for Eagle Technology. Feel free to ask any questions during this webinar. We'll try and get to all of the questions, but if we do run out of time, we'll send you a response individually. So we all know IoT and predictive maintenance has become a hot topic. Many manufacturing and industrial companies are feeling the pressure to move away from traditional processes to a more digital approach. Joining us today for a webinar, we have Aaron Mull, the co-founder of Towards Zero and partner of Eagle Technology. He's going to walk us through the value of integrating CMMS with factory floor systems like Historian and MES, as well as how you can use data to reduce maintenance staff hours, spare parts spent, and machine downtime. He's lived it. He's going to share his wisdom with you today. So let's get started. Aaron, thank you for joining us today. Before you jump right into it, can you please tell the audience a little bit more about yourself?
Yeah, thank you, Barbara. I'm Aaron Mull. I'm the co-founder of Towards Zero. We founded Towards Zero really to focus on driving waste out of manufacturing using technology, using changes to process, and culture change. I have a 20-year background in manufacturing with all kinds of different technology, from control systems to supervisory systems to ERP integration. And we've got a great team that has done just about everything you can think of from a manufacturing technology perspective. I appreciate the time to talk to everyone today.
Okay, thank you, Aaron. I'm going to give it over to you again so that you can start. If there, like we said before, if there's any questions, please feel free to fill them in, and we'll get to them at the end.
Okay. So what we're talking about today is the data that's on the shop floor and how to use it for maintenance purposes. Everyone's probably familiar with lists like this, but those machines, those systems, they have a wealth of data that typically in most manufacturing plants, maintenance staff and control engineers are using after something occurs or after the fact to troubleshoot why a machine's down, why something failed, why a process is out of control. And what we're going to talk about is using that same data proactively, so to recognize things that are going to happen, or to trigger preventative maintenance based on actual runtime hours instead of based on calendar events. So let me switch to the next slide. Hopefully, there we go. So typically, from what we see in plants, is maintenance departments schedule preventative maintenance based on days, weeks, months, right? So it's the original vendor that manufactured the machine or the component on that machine provides recommended maintenance procedures, and typically what's put into the CMMS is preventative maintenance based on how long they think the machine's going to run in a certain period of time, right? And by using data on the shop floor, we can actually now schedule preventative maintenance automatically based on real runtime, right? So think about a motor. Maybe you need to change the brush out, and we can actually track either through that control system or through the supervisory system on top exactly how many runtime hours that motor has, and trigger a work order proactively or automatically based on the amount of time, right? And the savings there are pretty obvious. What that does is it reduces the amount of time that the maintenance staff spend doing preventative maintenance, right? Because if you're, instead of scheduling it once a month, let's say, maybe it's going to be scheduled every 38 days. Maybe the machine or motor doesn't run as often as was estimated originally. And that also cuts down on spare parts. So less PMs, less hours spent, and less spare parts. The other thing we can do with that data is alert maintenance staff that something's going to happen before it happens, right? So, this takes a little bit more knowledge of the system itself in order to set those limits. Typically, what we recommend is giving the maintenance staff a tool where they can change those set points themselves and change the thresholds that alert them. We're all bombarded with too many emails and too much communication these days, and so it's important not to overdo this. But the idea here is to look at critical assets and look at, why did it go out of tolerance, or why did it break the last time? What can we monitor in order to alert us that it's going to happen again? So here's some good examples. Motor speeds, right? So a motor running faster than it should. Motor torques, that can signal that something else, maybe it's not the motor itself that has the problem, but something in the system. The motor has to exert more effort to do the same amount of work. So that means there's a jam, there's a break, something to that effect is going on. Currents, same kind of idea. It's another way at looking at the load on the motor. So if the torque's not available, a lot of times through that drive, you can get the motor current. And then simple things like lubricant levels. Sometimes those are available through the control system or through the supervisory system. Sometimes they aren't. But if they are available, they're extremely valuable and they're extremely useful. And what we do with those is we notify staff when they're out of tolerance or they're out of spec. And so that way maintenance staff can go look at that proactively hopefully before something breaks. So those last two examples were really looking at real-time data straight from a control system. There are other tools on the shop floor that take that data and record it historically, right? And so typically the way that data is stored is a process historian. Process historians have been around for a long time. I know we're talking about IIoT and kind of the new, the next step in using data on the shop floor. Process historians have probably been around for 20 years. These are the most common ones that you'll find. Just about every plant out there has one of these running in it. And what they do is they store time series data. They are very good at it. They can store it quickly. They can store large amounts of it. And from a maintenance perspective, we can use that data to not just look at something going out of tolerance in real time, but now we can go back and look at it historically and begin to mine that data and look for trends, look for things that have happened more than once, and kind of correlate the event that happened with the actual data itself, which allows us to set even more intelligent alarms and alerts for the maintenance staff to go take a look at it. Which leads us to predictive. So the common theme, there's a lot of vendors out there that are talking about predictive analytics and next generation software and all the cool things you can do with it. The common factor behind all of those is the need for data. They all need some sort of historical data archive to look at, to run the analysis, to build the models on top of. The more data that you have, the longer that you've been recording that data, the better your analytics are going to run, regardless of which vendor you select. And that's why we're at Towards Zero, we're big fans of using a process historian to record that data. There's numerous examples out there of companies recording data into a historian without knowing the use case yet, right? We don't always know what we're going to solve with that data. It's one of those chicken and egg conversations. But a lot of those problems would not have been solved if the companies hadn't had the data available, right? So sometimes you're recording that information and you don't know why you're going to use it, and it's hard to justify that cost, right? In today's day of, not a dollar being spent without an ROI behind it. It's sometimes difficult to get management to say yes to something like that. But historians are getting less and less expensive. The more competition there is, the lower the price points, and hard drive space is cheap these days. Don't throw your data away. Even years down the road, you could find a good use for that information, especially when you're looking at assets, right? There are some predictive tools out there that require at least a year, a minimum of a year's worth of data, just to run the models that are going to do some root cause analysis. And these are packages that are looking at every possible variable you can think of. There are examples of packaging lines where there were labels slipping on that machine, and the root cause was actually the amount of humidity in the air. So we needed the data on the packaging machine itself from that packaging machine, and we also used the data from the building management system. And by correlating that, we were able to determine that it was actually the humidity causing the problem, not the vendor, which was the original thought, that it was the actual label manufacturer themselves that were to blame. It was actually the glue. And when the air is more humid, the glue dries slower than it's supposed to, and that's why the labels were slipping off. So there are a lot of examples out there where problems on the equipment that maintenance staff have been asked to address are actually process problems earlier in the value stream. Examples like humidity are not that uncommon. Now we're becoming more and more aware of those other variables we should be looking at, and that started by analyzing through the predictive analysis tools. So raw time series data is valuable. There are also a lot of systems on the shop floor that have contextual data that's valuable. We spend a lot of time with OEE systems. For those of you not familiar with those, it stands for overall equipment effectiveness. And ultimately what those systems are doing is they're asset focused, just like a CMMS, but more from a production standpoint. So they're looking at production counts compared to targets, like this machine or this line should produce X within this 8-hour shift. We produced Y. We're Z below our target of X. That's one of the metrics in OEE is actual production counts. The other two metrics are downtime events, when they occurred, how long, and the systems categorize those downtime events, and scrap events. So product was produced, it's not to spec, it's either rejected or sent for rework. In either case, that counts against your OEE score. And the metrics that are extremely valuable in an OEE system are those downtime events for a maintenance staff. Because not only will the system tell you when it occurred and how long, since it categorizes it, you're able to look at common events. And oftentimes operators will enter comments in that help really determine what happened and why it happened. And companies that put in OEE systems are often surprised by the number of common events that happen that are tiny in nature, small, so only a minute or only 2 minutes in length, but since they occur dozens of times, that can add up to quite a long period of lost production. And so that information tied right into a CMMS is extremely valuable. Oftentimes it's used as part of a continuous improvement program, and maybe it's not the actual event that we tie into the CMMS, but we look at those events, we go and we look at the raw data that in that historian or in that OEE system during the times of those events, and allows us to set up more intelligent alerts and alarms, and sometimes more intelligent automatic work order creation activities. Like an OEE system, the next one on the list is a manufacturing execution system. Sometimes MES systems include OEE functionality, sometimes they don't, depends on the system. But they all include some sort of contextual data that's valuable to maintenance. The example that we have on the screen here is talking about calibration dates, and especially in discrete industries or food, a lot of these systems will track when a gauge needs to be calibrated, when it was last calibrated. A lot of them will track the information for a weigh scale, for example. Those are simple examples of using those dates to trigger that calibration activity. There are other rich sets of data in those systems, just like OEE, that allow you to look at events, like when problems occur, when maybe there's a non-conformance, maybe there's scrap. Again, that's the type of information that allows people to proactively sit down and say, okay, how do we make sure that next month there's less of these events? And oftentimes that takes multiple departments working together. That's not just maintenance, that's quality, that's production. But some of the activities that shake out of those meetings and result from that are maintenance activities, and the better maintained that asset is, the better it's going to perform, as we all know. And last on the list are statistical process control systems, or SPC systems. You know, these are systems used by quality departments to look at really product specs and actuals and how they change over time. So if you're making multiple of the same product, the quality department looks at drift and, hey, we're slowly moving out of control from where we need to be. And oftentimes that can be traced back to something that needs to be maintained or proactively changed on a machine. In CNC machines, that can be the tooling as it wears down and needs to be replaced. It's another activity that most companies are replacing that tooling based on calendar events. As we get access to more data on those CNCs, now we can replace the tooling or retool it based on number of runtime hours by the actual tool itself. Same kind of situation with the measurement devices, or just parts in general on a machine becoming loose, or go back to belts and chains and things like that. Those can, as those wear out and they need to be replaced, that can affect the actual product quality. And you'll see that in an SPC package. Those SPC packages are designed to show you that you're drifting out of tolerance, and that data can be used to trigger maintenance activities as well. So hopefully those use cases and me talking has kind of stimulated some ideas in your head about what would be useful in your specific plant. Every plant's different. Every process is different. You know, even the same products made at different plants have different systems and different technology, different assets underneath them. You know, oftentimes purchased at different times. And so which data is useful and which data is valuable is going to be a little different from plant to plant. How we get the data is fairly uniform. There aren't too many unique ways of getting that data. From the control system, so real-time data, OPC is the recognized standard out there. That's the same method that those supervisory systems use to get data from machines, right? And ultimately what we're doing is we're grabbing the data right from the control systems themselves. So each PLC or CNC controller or robot, depending on the vendor, they have proprietary protocols that are used to communicate with them. The vendors publish those, they make those available, and there's sometimes vendor software, sometimes third-party software that acts as a translation service and converts that proprietary language to the universal OPC language. And that's how we use that data to get into Proteus, to get it into SCADA systems, MES systems, OEE systems, you name it. That's the standard way of getting data out of control systems. There are a couple, depending on the industry or the type of machine, there's a couple other file-based methods to get data out of machines. CMMS for quality are going to produce files. Some machine tools produce data in the form of MT Connect. but even some of those file-based data standards can be converted to OPC. For those systems that don't just produce time series data, so when we're talking about OPC, that's time series data. That's the name of the point, that's the value, that's the time at which we grab it. For more contextualized information from a process historian, from an OEE system, from an MES or SPC, the method of choice that we always recommend is using the API. What that means is, for that software vendor, they have a separate piece of software that allows you to request information from the system, and it's using a standard method. It's not going directly to the SQL tables. And the advantage of going through the API is, as those vendors upgrade or enhance their software, a lot of times they'll make changes to those SQL tables underneath. And when we do direct SQL integration, that can break as versions are upgraded. With that said, there are still cases where we do recommend integrating directly to SQL. If your vendor provides you a map of the SQL tables, it's fast. It's not difficult to do. So you can oftentimes do it faster with direct SQL integration, but it's not going to be as nice of a long-term solution. So what do we see happening in the industry? Well, the term IIoT is being used all over the place. Just about every manufacturing technology vendor's jumped on the IIoT bandwagon. We hear IoT used as well. So for those of you who have heard both and wonder what the difference is, from what we can tell, IIoT is Industrial Internet of Things. So that's really referring to data being pulled from devices in an industrial environment, like a manufacturing plant or a power plant or a wastewater treatment plant or something like that, where IoT, so you've dropped the industrial part, now it's just Internet of Things. That's talking about information or data that we're pulling from consumer devices, refrigerators, cars, traffic signals, things like that. That's kind of the dividing line. It's a lot of people, if not most people, use them interchangeably. Doesn't really matter. The whole idea is pulling data from a device and using it for some sort of analytical purpose. And guess what? It may be a new term, but the technology underneath oftentimes is technology that's been around a long, long time. It's OPC. It's using APIs. You still need a plant network. It's not going to use Bluetooth. You're still going to need some sort of TCP/IP based network. What is happening is the costs are going down. So the technology may not be as state of the art or new as marketing departments lead you to believe, but the good part for all of us is that the cost of using it is going down. Hardware costs have gone down. Just with computers, we used to worry about how much of a hard drive we were using and design around that. And while it's still important, it's not nearly as important as it was years ago. Software costs are going down. Labor required to do these things is going down as the tools become easier to use, more efficient, more functionality is built into them from the very beginning. Then it takes less labor to actually get them running and build the applications. What's not going to change, what hasn't ever changed, is data. You're going to need data. And in order to do some of these things, not only do you need data, but you need to collect it and organize it in a way that makes it easy to go find it. I know I get overwhelmed with data. I get more emails than I can handle. We all get alerts from news organizations and what our kids are doing at school, and it's overwhelming just in our personal lives, and it's even worse in a manufacturing plant. There are standards around reducing the number of alarms that people see from their systems. And so as we collect more and more data, we have to find ways of using it that flashing lights and alerts to people's cell phones. That's not gonna improve things. It has to be smarter than that. It has to do some of the work for people, and in order to do that, it's all about organizing that data. So don't throw it away. That's our recommendation. Collect it, store it, have some sort of standard around how you do that, from a naming convention to location, so that everyone in your organization's on the same page, and that's going to make it easier to use it, whether you're using it this month as part of a proactive strategy, or whether it's a year or two down the road. Organize it. So we get asked all the time where to start and what method people should use, what technology people should use. And the answer that most people don't like is the depends answer, right? It depends. But it really does. It depends on what systems do you already have running in your plant. You know, that's going to help determine what your strategy should be. It's going to depend on what data is available. It's always interesting. The assets that are most beneficial to this kind of strategy are typically the assets with the least amount of data, because they're the older assets. The assets that are the most difficult to maintain, the most problematic, are going to be the most difficult and expensive to get data out of. They've got older PLCs on them. A lot of them don't have an Ethernet port. And so in order to get that information, we have to add some sort of hardware gateway. We have to add an Ethernet card. Whereas the newer, more modern machines, not only do they have connection available, they typically have more sensors and more information for us to grab. So when we take a look at a fleet of assets in a plant, it's often a kind of an inverse correlation where it's kind of the assets you would think of to start with are oftentimes not what we start with. And that's because of a cost consideration. So typically we're starting with the newer assets that maybe have quality issues, or the assets that are kind of fall in the middle there. They're not as new, not as old. They have communication available, and they have downtime events that we can focus on, pulling the data, making it available. Once that connection's made, part of the cost of doing this is the infrastructure itself, the plant network, the communication cards, and once that investment's made, that's a big piece of doing this. So put that historian in, save it, collect it. That's the cost of that historian is typically far, far less than the actual infrastructure itself, that plant network. And it's difficult to justify putting a plant network in just for a maintenance activity, just looking at a downtime event. But when you look at your entire IIoT strategy, then it becomes a lot easier, because that same network's used for the production department, that same plant network's used for the quality department. So a lot of times by putting together a complete strategy instead of one initiative, but a strategy that includes multiple initiatives across multiple departments, justifying that cost becomes a lot easier. And that's something we can help you with. That's what we're really good at. We can come in and take a look at how will this not just justify the maintenance department, how will this not just help production with reducing downtime events, but how will this help the quality department with their initiatives? How will it help the supply chain department? The same data that's used for maintenance purposes can be used by the production planner. They want to see what kind of downtime events are happening. They want to see what kind of scrap events are happening, because that's going to affect their plan. That same information can be used for a corporate. If your plant's part of a network of multiple plants, those ERP systems want information too. And again, that same infrastructure cost, that plant network, those communication cards, the OPC server, that historian, those are foundational pieces for any IIoT strategy. And by combining those initiatives, it becomes a lot easier to justify the cost. So, that's kind of our presentation. We can get into the specific use cases where we've looked at specific pieces of equipment and what kind of data we've used to drive these types of initiatives. I think, Barbara, you wanted to open the floor back up for questions. To summarize, really, it's all about having good infrastructure, collecting that data. That's the first step. Once you do that, now you can start being proactive about it and tying that into the CMMS, automatically creating work orders, reducing the number of PMs, reducing the amount of spare parts, and ideally reducing the amount of firefighting that the maintenance staff does, where you're now alerted about problems before they happen. You can go take control. So I think the next slide is Q&A.
Yeah.
Yes.
Thanks, Aaron. I think that was quite insightful. I know as we're nearing the end of 2017 and people are trying to hit 2018 head on, we keep hearing that we have to have the data, and it's hard, I think, for a lot of people that, hey, you know, we have the data, but what do we do now? And I think it's a question that it takes more of a one-on-one on a situation, like you said before. It depends. So I think if you can please just tell the audience where they can get a hold of you if they want to further this discussion, if they want to maybe just see what they have already, what processes they could have put in place to further it.
I would say start with the machine connection first. In a lot of plants that exists for other systems, and you can take advantage of it from a Proteus perspective. If that's not documented, go do a simple audit. Are we connected to the machine? What data are we? Why did we connect to it? What data are we pulling? And if we're not connected to the machine, what does that control system look like? Open up the cabinet, look for an Ethernet port. If you don't see an Ethernet port, take a photo of that controller, the PLC or that CNC controller, look and make sure there's an empty slot, because that's going to allow you to add that communication card, and then go do quick research on the web of what protocol you need. The OPC packages that are out there, they can talk to just about anything these days. Some things are easier than others, but that's where we recommend getting started. And if you have that network in place, if you have that connectivity already, then the next step is to see if you have a process historian. So by having the network, that means you have real-time data. That means you can access that data every time it happens. That historian will record that, so now you can go back and look. You can trend it, and eventually you can run predictive analytics against it.
Is there an email or something that people can reach out to if they have questions they feel they want to just ask you or further the discussion with you?
Yeah, of course. So my email is aaron.mull@towardzero.com. My phone number is 877-272-4501, extension 720. And I'd personally love to talk to you and discuss your strategy and what you're trying to accomplish.
Is there any other questions from the audience today? Is there anything you guys want to ask that you feel you want more information on, or something that we can answer for you right now? You can fill it into the question box with your control panel. Okay. I'm not seeing anybody or any interaction further, so with that, I'm going to thank you, Aaron, for taking the time to share your knowledge, and for those of you who joined us today, thank you very much. We will be sending you a link of this recording. If you have any questions or you would like a demo of our CMMS software called Proteus MMX, or just even further discussion with Aaron, please email us at webinars@eaglecmms.com. We have it here on the screen, and then we also have Eagle's website as well as Towards Zero. So feel free, visit us, call us, even if you just want to have a chat. Let's see how we can help you. Aaron really did put it out there. Everything's moving to data, and I'm sure between Towards Zero and Eagle, we can literally help you put that data to use. So thank you everybody for coming. If you have comments, feel free to leave them when we do close off the email and the webinar. And if there is, like I say, anything, email us. Let's have a chat. Thank you.